Hello everyone, my name is Vytautas and I work for the Leibniz Supercomputing Center in Munich. Today I will be talking about EasyVVUQ, which is uncertainty quantification, validation and verification framework written in Python. It's part of the VECMA project funded by the European Union's Horizon 2020 grant. What is EasyVVUQ? So it's a Python 3 library, which simply means that it's written in Python 3. It doesn't mean that it's meant only for Python software. In fact, you can use simulations written in Fortran or C++ or whatever with it, and people do. So it generates input files for your simulation. The input files are generated to sample the parameter space according to whatever you specify, the distributions and so on. It orchestrates the execution of such simulations on HPC or cloud resources. It then gathers and analyzes the results, and then you can act accordingly. It has a modular architecture by design, so it was meant to accommodate as wide a variety of simulations as possible. And as I said, it's written in Python. Now, if you want to check it out, you can download the source code from GitHub. We also have continuous integration and deployment script set up, so that each release is automatically published to both pip and Anaconda, whichever you prefer. And we have a Jupyter Notebooks based tutorial, which you can check out by going to the link at the bottom of the slide. Now, there isn't really enough time to go in depth into the workflow, but this would be an example of EasyVVUQ script. So we create a campaign, we describe the parameter space, then we have an encoding step which basically specifies how to generate the input files for your simulation. Decoder parses the outputs of said simulation. Then you have a sampler which will generate the samples. From those samples, then you create the input file for the simulation. In this case, it's using a polynomial chaos expansion sampler. Then you essentially execute the simulation, gather the results, and perform analysis. There are several ways of executing the jobs on HPC resources. For example, we support the task job queue or QCG pilot jobs. Again, more details can be found on the website or on the GitHub. To highlight some features, so currently we support quasi-Monte Carlo, stochastic allocation, polynomial chaos expansions, and basic statistics as far as analysis goes. Then you can execute your simulations using QCG Pilot Job Manager or task job queue, or locally for testing purposes. Everything is coordinated via a backend database. So everything is designed to give you the opportunity to do this with as little pain as possible. Then there is a paper in press summarizing the current users of the framework. But just to summarize, it's used in material science, ocean circulation, nuclear fusion, forced migration, and urban air pollution modeling. In the near future, we plan to add support for cloud computing via Kubernetes and Dask. And I would like to invite you again to check it out. Thank you.